Hello, my name is Sunnie. I'm a PhD student at Princeton University, and I'll be sharing our work, Humans, AI, and Context, Understanding End Users' Trust in a Real-World Computer Vision Application. This work was done with Elizabeth Ann Watkins, Olga Russakovsky, Ruth Fong, and Andrés Monroy-Hernández. Trust is a key factor in people's interactions with AI systems. Hence, to better understand trust and foster it appropriately in human-AI interactions, there has been significant empirical work investigating how a certain factor affects trust. Most of these works conduct carefully controlled lab experiments to draw causal conclusions about the factor's effect on trust. In this work, we take a different approach to provide complementary insights. We qualitatively explore what factors affect trust and how in a real-world context. And we do so by interviewing real end users of an AI application about their trust relationship with the AI. Our research setting is the Merlin app for bird identification. It is a free mobile phone app that uses computer vision AI models to identify birds in user-uploaded photos and audio recordings. We chose Merlin because it is a real-world AI application with a wide user base, while satisfying the requirements of commonly used trust definitions. Here's a quick summary of our study methods. First, we recruited Merlin users with varying domain and AI knowledge base as our study participants. Second, we conducted semi-structured interviews and asked participants about their context of app use and trust in the app from many angles, including goals and stakes in app use, experience with the app, general perceptions and attitudes towards the app, instance-specific behaviors with the app, and intention to use the app in hypothetical high-stakes scenarios. Afterwards, we transcribed the interviews and analyzed the transcripts using abductive coding, meaning our data analysis was an iterative process where we moved between empirical data and available theory. Concretely, we used Mayer et al.'s trust model as a high-level framework. We chose this model because its process orientation fit our work's objective of holistically understanding trust, while cleanly delineating trust from its antecedents, context, and products. Further, its trust definition, shown on the slide, is one of the most widely used trust definitions in the literature. Based on Mayer et al.'s model, in our analysis, we separated trust from trustworthiness perceptions that precede it and trust-related behaviors that proceed from it. Starting with trustworthiness perception and trust attitude. Overall, participants assessed the AI application to be trustworthy and trusted it. Going over the three factors of perceived trustworthiness, participants assessed the app has ability based on their positive prior experience with the app and the popularity of the app. Participants assessed the app has benevolence as well, based on the reputation of the app's domain, birding. They described the birding community, which they and the app developers are a part of, as a place where everyone tries to be accurate and do good. Finally, participants assessed the app has integrity based on the developer's reputation. Most participants knew that the app was developed by the Cornell Lab of Ornithology and described it as a respected institution with a long history of bird science and conservation efforts. Based on these responses and participants' descriptions of their attitude towards the app, we draw the conclusion that the participants trusted the app. However, we observed a more complex picture of trust where we examined participants' app output acceptance, which is an instance-specific trust-related behavior. In short, participants selectively accepted app outputs after verifying to the extent possible. Participants carefully assessed the app's outputs based on their likelihood and task difficulty. For example, participant 6 said, if it's a common bird or even just a rare bird, uncommon or something like that, then maybe. But if it's a super rare bird, then definitely not. Participants also actively verified the outputs. For instance, participant 10 said, I go back and look at reference photos of that bird and then try to map field markings. So I'll try to see if the bill shape lines up. Other participants said they compared the app's output to their own identification or consult other birders. Some participants disregarded the outputs when they could not verify them. For instance, participant 18 said, "I never count on my bird registry. Anything that Sound ID says that I can't kind of confirm, either through the facts of it or through a visual ID," even though they had a positive assessment of the app's ability and trustworthiness. However, not all participants had the ability to assess the correctness of the app's outputs, as captured in this quote from participant 12. "Since I know so little about birds, I can't actually judge its accuracy." The final aspect of trust in AI we analyze is how participants made AI adoption decisions, which is another type of instance-specific trust-related behavior. In their actual use setting, participants never decided against using the app. When we asked them how they make AI adoption decisions, they only described situations where they decided to use the app, and never situations where they decided against it. However, when we presented hypothetical high-stakes scenarios, we observed a different decision-making process around app adoption. For context, in the sick bird scenario, we asked the participants, "You find the sick bird and take it to the vet. Both of you are unsure what bird it is. Would you use Merlin to identify the sick bird?" And in the game show scenario, we asked the participants, "You enter a game show where you win or lose money based on how well you identify birds. You can only use one resource. Which resource would you use?" In these high-stakes scenarios, participants made app adoption decisions more carefully, considering various factors. To begin, participants considered the app's ability with respect to various situational characteristics. For example, for the sick bird scenario, participant 4 said, "Assuming that I don't know what the bird is and they don't know what the bird is, this bird is some ambiguous-looking bird. In those cases, I don't think Merlin would be able to know." For the game show scenario, some participants said they would choose the app if there are time constraints, but otherwise choose a good quality field guide or consult other birders. Participants also mentioned factors such as ease of use, familiarity, and their ability to use the AI. For example, participant 4 said, "I definitely would use Merlin because I'm familiar with it and I trust my ability, like I know how to operate it pretty well." In summary, we found that end users' trust in AI is multifaceted. Generally, participants found the app trustworthy and trusted it. Still, they carefully assessed the correctness of individual outputs and decided against app adoption in certain high-stakes scenarios. Hence, we strongly encourage the community to approach trust holistically and consider both general and instance-specific aspects when thinking about trust. We also highlight that trust in AI is influenced by many factors as organized in this table. Human-related factors include domain knowledge and other factors influenced by it, such as the ability to assess the AI's outputs, the ability to assess the AI's ability, and the ability to use the AI. AI-related factors include internal factors such as ability, integrity, and benevolence, external factors such as popularity, and user-dependent factors such as familiarity and ease of use. Context-related factors include task difficulty, perceived risks and benefits, situational characteristics, domain's reputation, and developer's reputation. We emphasize that this is not a complete set of factors that can influence trust in AI, but what we observed in our case study. However, we hope this table can help researchers anticipate what can influence trust in AI in their context of interest. Thank you, and please check out our paper for more details.